Now, so the same cube function that we had here, okay, so we can redefine that cube function without giving it a name, right? So for example, I can just treat that as x is of type integer, okay, okay, and this returns, okay, now x star, x star, x, okay. Now observe, earlier we did this cube function, right? Where is that cube function? Okay, so we had defined a cube function here right at the top, right? So we said cube, define cube, takes in an integer as parameters and returns integer, blah blah blah, right? So instead of that, now I'm just trying to write that without any name, right? So this is basically an anonymous function, right? Here, okay, so here x of int is basically the parameter that you're passing to the function, okay, and whatever is there to the right of this equal to greater than symbol is basically the body of the function, okay. So the return value of this function is the result of this expression. So this is another way of defining a function. So here you are not giving any name to this function, rather you're just creating a function on the fly. This is basically an anonymous function. Now if you recall, you can say in this sum function that you had, okay, which is going to take a function here as a parameter, you didn't have to write a code which to actually define a function, right? So you can simply pass this as a parameter because this is a function, right? So if you observe here, now the result of this is nothing but a function, right? So it says a function. This function takes an integer as a parameter and it is returning an integer. So why is there y equal to there and equal to greater than here, right? Because this is an anonymous function, okay? So we have to indicate this as a function, right? So this parameter, this is like this is something which indicates that this is a function. So what you're doing here is you're using this. It would take whatever is right of this parameter as the body of this function. That's all. Okay, so this is another way of defining a function. So here we had just one parameter to this function, right? So supposing if you wanted to have multiple parameters, you can just put some commas and create it, right? Say for example, I'll say x of int, okay, comma y of int. Now you say this is an anonymous function which returns x plus y, right? So you can use commas to basically add multiple parameters to this function. All right. Now, using this kind of anonymous functions, okay, so you can actually write your functions in a much shorter fashion, right? So the same sum of ints, okay, the sum of ints which we defined earlier, right? Now I can rewrite the same thing, by instead of trying to pass that another function that I created, the ID function. So I can write the same sum functions. So I already have a sum function, okay, which takes. So let me revisit that. Where is that sum function? Okay. So for example, right? So here this sum of ints, okay. Now if you observe, I'm passing this function ID and and so on, right? So this sum of int, I mean, like whatever we did here, right? Now the same sum of ints, I can redefine it in this way, right? I can say def, okay, sum of ints, okay. Now I'll say this takes two parameters, a which is of type integer and b which is of type integer, okay. and I say is equal to sum of, okay, I will say now this, I'm going to not, I don't require a function because I know this sum function here basically takes, if you observe here, the sum function takes a function as an input parameter, right? So I'm going to use the same sum function for, here, okay? So the result of the sum function. So I'll say sum of, I'll say x comma a comma b. Okay, now try to digest this. Okay, so what did I say here? So I mentioned here when we are creating an anonymous function, okay, now we mentioned x, and x is of type integer, and some expression here. Okay, now I also mentioned if there is only one parameter, or rather if the type of this x can be understood from the context, okay, the compiler allows you not to even put this input parameter type. Okay, so if you remove that input parameter type, now observe here, this basically becomes a function, okay, which takes in an integer as a parameter, and it results into an integer. It returns an integer. Now that matches the signature of whatever the sum function that I had defined here. So this sum function takes some function which takes an integer and returns an integer. Now, this anonymous function here is doing the same thing, right? So the sum function, I'm passing this anonymous function which takes in one integer and basically returns the same integer, right? And then I'm passing a comma b, and so this sum function simply takes this and applies this on this to calculate the number of integers between the sum of integers between a to b. A valid function which is basically returning an integer. Okay, so now I can rewrite the sum of cubes. Okay, so I'll say sum of cubes in the same fashion. So a which is of type int, b which is of type int, equal to, I'll say sum of, now I'll say take one parameter, a function which takes one parameter x and basically returns x star x star x, okay, comma a comma b. Right? Okay, between 2 to 6, right? So it's giving you the result here. So what is 2 cubes? So 2 cube is 8, 3 cube is 27, 4 cube is I think 64, 5 cube is 125, and 6 cube is something. So all put together it's 440. Right? Or you want to do a sum of ints, easier to compare. So 2 comma 6, so that's 20. Okay, now listen to this very carefully. So if you follow this part, I think you will be able to make sense of all these different kind of syntaxes that are available, right? See, if one function is passed as a parameter to another function, okay, now Scala helps us in deducing the data types wherever possible, the return values. Okay, so for example, see, in this whole exercise, I'll try to show you how you pass in an elaborate way, passing functions, and then basically using this mix of anonymous functions, the rules of anonymous functions, how you can simplify that whole process, and you get this whatever the weird logic that you think it is, right? So now let me write a function. Say I'll say def value at value at 1/4. So this is a function. Now this function, um, I'll say it gives me whatever the value you're passing. It's going to give me a quarter of that, right? So it's basically gives me the value into 0.25 times, right? So let's say I'm going to pass a function as an argument to this function. Okay, so I'll say the name of that function is f. Okay, now this returns basically a double. Oh, sorry, this takes a double as a parameter. Okay, and it returns me a double. Okay, and I say this function is equal to f of 0.25. Okay, now try to understand this, what we're trying to do here. So we are trying to define a function called as value at 1/4, and this function basically takes a function as a parameter. Okay, and the function f basically takes a double as a input to it, and it returns basically another double. Okay, so in the body of this function, what am I doing? I'm simply taking this function, I'm calling this function with some value 0.25. Okay, so what it does is basically it it returns this this 0.25. Okay, now so this value at 1/4 function, okay, it takes in a function which takes a double and returns a double, and then this function itself returns a double. Okay, now the same thing can be written in a different way also. I mean, it is the same as, for example, I'll say value at 1/4. Okay, supposing if I'm having something like this, I'll say x, which is a double. Okay, and so I'm going to call this value at 1/4 function by passing another function, okay, which returns, okay, 3 times x. Okay, observe here. So what am I saying here? So this value of 1/4 function takes a function which returns a double. Okay, so when I'm calling this value at 1/4, I'm passing a function, okay, which takes a double and returns a double. Okay, so it is 3 times the double, right? So that's what is this function doing, right? So all right, what happened here? I'm sorry. To make this a function, I have to put this, right? So can you see the result here? I'm basically passing a function, okay, to this value at 1/4, and that was basically getting. So it is simply returning that with 0.25 of this function, and so it becomes. I mean, 0.25 is passed on to this, and so it is 0.25 into 3. So therefore, it is 0.75. Now, the same thing, I can rewrite this function, okay? Now, using the rules that I just now defined, okay, I can rewrite, okay? So I said that, the Scala compiler, based on the context, it will, see here what we, we did not specify the parameter type here, right? So we automatically created an anonymous value. For example, in this sum here, right? I did not specify the input data type, right? And I did not specify the output data type. So compiler inferred it, right? So I can do the same treatment here also, right? So for this anonymous function, I don't need to pass this parameter, this x of double here, right? So I can make another call by not having the double, right? So I can simply say it as x here, right? So it still gives me the same result, right? Because compiler is trying to fix this. So it based on the context, it will take it, right? So now this is same as this, right? Now another interesting feature, okay? Now supposing, now Scala makes it even more, Scala compiler is even more intelligent, right? See, supposing if there is only one parameter that you are passing to a function, okay, there is no need to even put this brackets here, right? So if supposing there is, if there are more than one parameters, obviously you need to put this brackets so that you know that these are the input parameters, right? But if there is only one parameter that you are passing, you don't need this brackets also. So you can rewrite the same function without the brackets this way, right? It still gives you the same result, right? So that is because if you are passing only one parameter, then you don't need this brackets. If you need multiple brackets, multiple parameters, then you can put that and put commas and put it, right? So since there is only one parameter, I can just put it this way, right? Now, okay, now just hold on to this thought, okay? Now, if you recall our other, say when we are talking about the higher order functions, I use this underscore, right? So I use this underscore. What is this underscore operator is doing? It takes in, it takes every value of, that collection, right? Now you can use, that syntax also, right? Now, if supposing on the right hand side of this equal to greater than, on the right hand of this equal to greater than symbol, if you have the reference of this input parameter only once, okay? If you have this, if it is used only once in this, on the right hand side of this equal to greater than symbol, then you need not even specify the x here, okay? So instead, you can, simply replace that with underscore, okay? So you need not even have this x here, you can simply, reference this with underscore, okay? So I can rewrite this function by not even having this x, okay? So I can simply remove this line also, okay? And I can simply say this. Okay, so now observe here, it still gives you the same thing,